Okay, so when we're talking about a heap, it's a priority queue, as I said before, right? Now, a heap is a data structure as well, and it's actually my like quite an interesting data structure because it's a queue, and it's a queue that has priority. Think of it like this: if you're standing in a grocery store, okay, at the checkout, at the till, all right, in a line, in a queue, basically, and in front of you there's like 2 3 trolleys that are full, okay, full with items, and you just have 2 items, 1 or 2 items, and you are like waiting in line, and you're thinking if there's actually, a way where you as a person would be given more priority, okay, over the other guys who have full trolleys, so that you can check out first. That would save a lot of time, right? So that's what a queue does, a priority queue or a heap, okay, when you would be given priority. Okay, so you can check out first over the other guys. That's called a heap, giving priority. Now, there's 2 types of heaps: there's a min heap and there's a max heap. Okay, now the example I use right now, where because you had less items, you were given more priority over the other guys with more items. Okay, that's an example of a min heap, because the guy with the minimum amount of items has the priority, or is given priority. Excuse my English. Now, if the guys, or assume the man with the most items is given priority, that's called a max heap. So I have something here. Okay, by the way, a heap is implemented using, like, there's many ways you can implement a heap. You can show a heap using a linked list, you can show a heap using an array, you can show a heap using a tree. And for me, I find the most convenient way to be a tree. Okay, I just like trees for some reason. Now, I have a min heap here and a max heap, and the thing is that you can see in a min heap, the thing is that the minimum number inside the entire tree is the root. Alright, now then we have the number bigger than that below it, okay, the numbers that are greater than the root, and then we have numbers that are greater than both of them below that, meaning both of them as in the root and the first child. Okay, so you have to remember this is the rule inside of a min heap. Okay, the smallest item on top, okay, and the parent basically is smaller than the child. Okay, that's the rule inside of a min heap. Same with the max heap. Okay, in the max heap, the biggest number is the root, and the parent is always greater than the child. Okay, that's just something you have to remember. Now I close this. So then another thing, okay, would be this. Actually, it's hold on. Here we go. This, okay, min heap data structure. So you can implement a heap using an array as well. Okay, and if you do it using an array, then this is how it works. You first have to draw a tree. Okay, basically. Now your root is going to be the first element there. Okay, and then you're going to go like line by line. Okay, or think of it like this: because it's a tree, you get a family tree, and then inside of that family tree you have the first generation. Okay, then you have the second generation, then you have the third generation, right? So generation by generation you're going to put elements inside of the array. So you can see first comes that, then 16, then 31. So you can see 16 is here, 31 is there. Then we've exhausted this generation. Now come over here to this generation: 41, 51, 100, 115. So that's that. So that's just that array. Okay, basically the heap. It's quite amazing, isn't it? So now that's that. Alright, and then if there's something else I want to show you, but I'll do it in the next video. Have a great day.